Today we're talking about word problems that will involve exponential functions and how we can determine the difference between exponential and linear and even sometimes quadratic. But usually the AIR is going to ask you about linear and exponential. So key words that you're going to want, as you can see here, is that adding or subtracting the same number is going to be linear, or if it says it's a constant rate of change, linear. Quadratic is one that's going to talk about going up and coming back down. So almost like in the shape of a quadratic. So something that goes up and it comes back down. Exponential uses lots of keywords. They could say half-life, doubling, tripling, quadrupling. If it multiplies or divides by the exact same number, that's exponential. If they talk about a certain percentage increase, that's going to be exponential also. So now let's look at certain word problems down here, and we're going to try to distinguish between which one is which and how we would actually know it's that one. Okay, so the first one says you're trying to dunk a basketball and you need to jump 25 feet in the air to dunk the ball. So in my opinion, if you're jumping to dunk a basketball, you're going to be jumping like this. You're not going to try to jump straight up and down. You're going to get more air if you go at an angle. So that would be more of a quadratic model here. And that's how I knew just by the shape it would take you to do it. So the next one tells you we have 285 cell phone subscribers in a small town, and it's increasing by 75% each year. So that percent, since it gave us a percent increase, that's going to tell me that it's exponential. And the next one tells us we drink 120 milligrams of caffeine, and that it's going to decrease by 12 milligrams each, decreasing. That's linear, it's because it's decreasing at a fixed amount. The next one, we have a carnival game that involves ringing a bell, and it wants to write an equation. So it tells you that it propels it up into the air and comes back down. So that's going to be the shape of a parabola again. So that would be a quadratic. Again, I know it's that just because the shape the ball is going to have to go, it says. The last one tells us that we're having an increase of 5% again. So percentage increase is an example of an exponential model. So you can read through these notes up here. The important part is that you know the equation for what linear looks like, and you know for the equation for what the, I should have circled this one, for an exponential function. So exponential here, so your starting amount, your base is usually the word like doubling would mean 2, half would mean the base is 1/2, or tripling, your base would be 3 here. And exponential we already talked about or the linear we already talked about in that section. So here are a few examples, and then we're going to try it now. So let's first practice writing the equation of exponential, because we've already had experience writing the equations of linear. So remember, A is going to be your initial amount. So like for the first one, your initial amount is C, is 6, so A equals 6, and it tells us it doubles each month over a period of time. So doubling is telling us that our B is 2. So you write your equation 6 times 2 to the x. So number 2, we start off with 8. So again, make your A 8. And this time it's telling us that it's tripling over the period of time. So we want to write our equation. So it'll be y equals 8 times 3 to the x. And that is a weird time symbol there. Let's try number 3. Scientists are studying wildlife. So we have 36,000 slugs, and that we're growing at an average rate of 5.8%. So this time, since they didn't tell us it's doubling or tripling, we're going to use the fact that your B is going to become 1 plus your rate as a decimal. So make sure that you write that as a decimal, not as 5.8. What it's going to look like is going to be y equals 36,000, 1 plus your 0.058 to the x. And we would simplify that just by adding those actually together. I just wanted to show you what it would look like separate at first. We put 1.058 to the x. Let's try the next one. It's the same idea. So we have the population of bacteria starts out, that's your A, and it's growing at a rate of 9.8. So you're going to have y equals 87,000 times 1.098 to the x. If you're unsure, you take your percent and divide by 100 in your calculator. That's how I'm getting the 0.098. Now we need to read these two, and we're going to decide if it's linear or if it's exponential. So the library has 8,000 books, and it's adding 500 more books each year. So that's adding the same number each time. That's why we're picking linear. So we have to start out at 8,000, and we're adding 500x each year. And this time we're starting off with 10. So that again is our A. But where count is tripling. So that's the key word to tell you that it's exponential. And we're going to have y, oh, y is already there, equals 10. That would be times 3 to the x.